Presentation, Abdullah Ahmed Omar Bahashwan. So we can hand over for presentation to you. This presentation on the high and low rate data sets for DDoS attacks against SDN networks.
Very good day to everyone. I'm Taifala Alamiki from University Science Familia. So my research title, as Victor said, restores a lightweight detection system leveraging mapping technique with Java feature selection algorithm for selective forwarding attack with local and noisy network of Internet of Things. So first of all, Internet of Things is referred to a collective network of connected devices. This technique facilitates the communication between the physical devices and the digital worlds. So the Internet of Things technology creates this communication between the devices and enable them to connect to each other in a network. As we know nowadays, this technology is widely separated in different applications. For example, we have Apple ecosystem and Huawei ecosystem. This is an example of a small network of Internet of Things. To continue, we have a technique here which is called the local and loosey network, which is considered the backbone of IoT network. In this network, the Internet of Things sensors are organized in a form called local and loosey network. So the integration of local and loosey network with the Internet of Things enable the IoT to facilitate in a wide diverse types of sensors across a wide array of IoT applications. So the security here is crucial. Why is crucial? Because these types of networks are extended to vital infrastructure, area of privacy and sensitive industrial process. So the security of a local and loosey network has become one of the most heavily studied researchers in the recent period, and it addresses a wide range of research initiatives. So as I said, the local and loosey network is vulnerable to a wide range of attacks, and these attacks can be internal attacks when the attacker node be a part of a network, or it can be exposed to external attack when the attacker node is outside of a network. Here we can see in this slide, RPL attacks can be classified into 3 attacks. I would like to mention here that the local and loosey network have different types of protocols, and RPL is one of the most popular routing protocols in this types of networks. And this protocol is vulnerable to different types of attacks. As you can see here, there is 3 main types: resource-based attacks, topology-based attacks, and traffic-based attack. And in abstract explanation, the resource-based attack, when the attacker attacks the resources of a network by sending a huge types of packets to the network. But in the topology attack, the attacker exposes the targeting the topology of the network, trying to destroy the topology of the network and then break down the network. And the last type is traffic-based attacks. Here the attacker aims to expose the network and try to steal some critical information from the network. Okay? So in this research, we focus on detecting one of the most popular topology-based attack, which is the selective forwarding attack. Here, this figure shows the current direction in RPL protocol. As you can see here in the slides, the current research direction of the RPL can be classified into 2 types: RPL security and non-RPL security. I think this slide is very most important for the researchers who are working in this field. So in this research, we're focusing on the RPL security and specifically the intrusion detection system. In addition, the intrusion detection system can be classified into subtypes, which is hybrid-based approach, signature-based approach, and anomaly-based approach. And in this research, we study the anomaly-based approach, which have several types: machine learning, deep learning, and hybrid approaches. So we have also another technique which is called the feature selection. Feature selection is one of the most popular techniques for dimensional reduction and improve the performance of intrusion detection system. So these techniques can be classified into 3 main types, which is called the filter method, rubber method, and index method. So basically, the filter method try to rank a group of features or make the evaluation based on mathematical expression. For example, one of the most important algorithm in these types is called the information gain, the mutual information, the entropy algorithm, and then the set of features will be evaluated using the machine learning algorithm. The second type, which is called the rubber method, is types of algorithms like the recursive feature selection, the meta-heuristic algorithm. These types is evaluate a subset of features. Then using machine learning algorithm, then this process will be repeated until get the optimal set of features. And the last type, which we have the embedded method, which is a combination between the filter method and the rubber method. So, as I said, the meta-heuristic algorithm is one of the most popular rubber feature selection technique. So, meta-heuristic algorithm has been widely used to solve different real-world complex problems. So, as we can see here, there's different types of meta-heuristic algorithm. There's evolutionary algorithm, physical algorithm, nature algorithm, swarm-based algorithm, and biological algorithm. So these types is used to solve different types of problems. And in this research, we used the particle swarm optimization, which is one of the most popular swarm-based algorithm. So selection for this algorithm is one of the most known algorithms and have a fast execution time and a few control parameters. And we used in this research for feature selection algorithm. So what we have been doing in this research, as you can see here in the figure, that the existing solution, the meta-heuristic algorithm, rely on the machine learning algorithm to evaluate a subset of features. So basically, we have a full set of features inserted to the meta-heuristic algorithm. Then the meta-heuristic algorithm, as you can see here in the left figure, the start agent start to generate the candidate solution. After that, it will input to the evaluation function, which is here we have the machine learning algorithm. So this process took a huge training time. Why is that? Because machine learning want to make the training model and production model, and this process is iteratively repeated and take a long execution time. So what we propose in this research, we use a new thickness function or evaluation function, which is called the ranking technique, which is known as the mutual information or entropy-based or another types of filter feature selection. So these new types of techniques can be considered lightweight. Why is that? Because the calculation here is depending on the mathematical base rather than the machine learning or deep learning algorithm. In addition, the proposed technique can be lightweight because it consumes less resources compared to the machine and deep learning algorithm. So here we can see the methodology of a proposed step. So our methodology is composed of three main stages. The first stage is vegetable preparation. So the main aim of this stage is to prepare the data for the second stage where the lightweight feature selection algorithm has been conducted. And lastly, we have the random forest space transaction for defining the evaluating the selected features in the second stage. So as we can see here in the figure below, that the data preparation has several steps, starting by traffic aggregation, data encoding, data balancing, data scaling, and lastly the machine learning evaluation. Where the second stage contains also several steps. Start by subset generation and updating, subset evaluation, which is clearly you can see here in the figure, in the middle that we used the mutual information and chi-square algorithm. And lastly, we have a random forest, which also contains several steps from model building and training, prediction, and then evaluation measures to evaluate the model. So, in short cut, this is the content of the second stage, which is called the live feature selection algorithm. So here we have in the left figure the binary DSO algorithm is connected with a feature ranking method, as we can see here. So basically, the binary DSO algorithm start to generate a random initial population. After that, these types of population are evaluated here using the feature ranking method, like mutual information or chi-square. After that, these features will be also passed to the exploration and the simulation phase, which is the phases of the binary BSO algorithm. So after this process, or after the algorithm completed, the optimal subset of features will be passed to the next stage, which is the random forest-based selective founding attack prediction, for building the model for training and protection of the model, and get the result in terms of execution time and resource consumption time, and also on the data naming metrics. So here we have the design of filter scenarios and topologies. So in this research, we investigate the performance of our protection system, as I said, against selective founding attacks. So we deploy the attacker node in different positions in the network. So as we can see here in figure A, but the attacker node in the red color cycle is near to the root node, which is in blue color node 0. So in this case, the attacker is very near to the root node, and it is important to evaluate the attacker in this position. Why is that? Because it's have an important position to the root node and can have a huge effect on the network performance. After that, we evaluate the performance in figure B in the midway position with respect to the root node. And finally, we evaluate performance in far location with respect to the root node, also to see the performance of attacker node in this position. So this is the free experiment we have in this research. So this slide shows the preliminary result and expected contribution. As you can see here in the table on the left side, that the performance of the proposed technique in the free experiment, as I said in the previous slide. So as we can see here in the upper table, that we compare the performance of a standard existing meta-heuristic algorithm, which is called here the binary BSO algorithm and random forest model. And the fitness function, as we can note it here, is we have 2 times the accuracy and the mutual information per proposed one. So in terms of accuracy, we can see overall in all experiments we have comparative result between the existing work, which is binary BSO algorithm, and the proposed technique, which is the binary BSO algorithm with the mutual information plus the random forest model. Because here we have the fitness function in the proposed technique is the mutual information. So after the algorithm evaluate and obtain the optimal solution, we also use the random forest algorithm to evaluate the optimal subset of feature, but only in the last stage. So we can see here we have 2 random forest algorithms. Here also, and we can see in the term of number of selected features, we have the similar subset of features in the first table, but in the second and third table, the proposed feature selection technique or the integration of a proposed technique is better than the existing solution. It is able to reduce the number of subset of features into 17 compared to the 26 in the existing solution. On the left side, we can see here in the figure the performance of a proposed technique in terms of accuracy, position, recall, and F-measure. We can see here in terms of these metrics that the proposed solution is achieved competitive result compared to the existing solution. And so some scenarios where our proposed techniques is overcome the existing work in terms of accuracy and F-measure. As you can see here in the upper figure on the left side, that the accuracy performance is a small improvement, but also we have in the F-measure of metrics. In addition, on the left side figure, we have also an improvement in terms of precision, and on the right side we have an improvement on the accuracy, performance, and precision also result. So despite of this small improvement in terms of various metrics, we have a major improvement in the term of number of selected features, and also we expected that the execution time of BSO algorithm will be improved. Why is that? Because the proposed techniques is faster than the existing techniques, which is the machine learning algorithm. Because as I said, it's evaluate a subset of features based on number of based on mathematical model rather than machine learning algorithm, which is needed training and protection technique. So, as a conclusion, we can conclude that the alternate result, but proposed techniques is overcome the existing solution in terms of number of selected features and in terms of various metrics like the accuracy, precision, recall, and measure. Also, we expected that after the evaluation, because it is still an ongoing research, but we will compute the time execution time performance, and we expected that we will get a better result in terms of execution time and also in terms of CPU and power resource consumption, which makes this proposed techniques is compatible with the resource constraint in the IoT environment. And also we notice that in the term of number of selected features, that proposed techniques is aimed to reduce the number of selected features to 21, 17, and 15 features in the scenarios. So we can also conclude that the proposed techniques is feasible to be used in IoT scenarios, and we get impressive results from that. And we also extend this work to identify other types of IoT networks attacks like free-floating attack and cyber attack. Also, we can investigate and extend this work to investigate other types of RPL topologies to identify the attacks in different types of IoT applications.